Have you ever looked at some data from a new program and just wondered, hey, does this actually work the same for everybody? Well, today, we're going to dig into the statistical tool that helps us answer that exact question. It lets us tell a really powerful story with our data. A story about change, about different groups of people, and, most importantly, how those two things might interact. All right, let's get into it. So let's imagine you've created this fantastic new program designed to boost student confidence. You run the study, you collect all your data, and now you're facing a classic research puzzle. You're pretty sure the program works, but does it work the same way for everyone? Like, does it boost confidence equally for male and female students? This is precisely the kind of question we're going to tackle. To make this super clear, we're going to follow a case study. A researcher has this exact puzzle on their hands. They measured student confidence before their program, then right after it ended, and then again at a follow-up down the road. What they really want to do is untangle how confidence changes over that time, and, crucially, if that pattern of change looks different from males versus females. Okay, so in our data story, we've got a few key players. As you can see, our main character is the confidence score. That's the thing we're actually measuring. Then we've got our two groups, males and females. Now, because we're comparing these different groups of people, we call gender our between subjects factor. And finally, we're tracking everyone's journey over time. Since we're measuring the same individuals at different points, that's our within subjects factor. Simple, right? Between subjects compares separate groups. Within subjects tracks the same people over time. So now that we have our stories set up with both a between subjects and a within subjects factor, we need a very specific tool to analyze it. And that tool, my friends, is the two-way mixed design repeated measures ANOVA. I know, it sounds like a total mouthful, but trust me, it's basically a superhero designed to solve this exact kind of puzzle. Let's just break that name down for a second, because it actually tells you everything you need to know. It's called repeated measures, because, well, we're repeatedly measuring the same people to see how they change. And it's a mixed design because we're mixing that within subjects piece, the change over time, with a between subjects piece, the comparison of our separate groups. See, it's the perfect blend for our study. So what makes this test so cool? Well, it's that it doesn't just give you one simple yes or no. Instead, it lets us ask three really specific and super important questions about our data, all at the same time. The very first question is all about the journey itself. It asks, did confidence scores change over time for everybody in the study, period? In other words, if we just average everyone together and ignore what group they're in, did the program seem to have an effect? This is what we call the main effect of time. All right, question number 2. For this one, let's just pretend time isn't a factor for a minute. We're just focused on the groups. This question asks, overall, is there a significant difference in confidence between males and females? Like, if you averaged out all three of their scores, would one group just generally have higher confidence than the other? This is the main effect of gender. But here it is. This is the one. This is so often the most interesting, the most important question of them all. It's called the interaction effect. It doesn't just ask if things changed or if the groups were different. It asks if the way things changed over time was different depending on which group you were in. Did the program work better for one group, faster, or was it the same for everyone? You know, the easiest way to get your head around an interaction effect is to just picture a graph. If there's no interaction, the lines for our two groups are going to be roughly parallel. They're both going up at about the same rate. But if there is an interaction, those lines are not going to be parallel. They might cross, or maybe they start close together and spread way apart. So, if you remember one thing, remember this. Look for those parallel lines. That's the key visual. Okay, so we've got our puzzle, we've got our statistical tool, and we know the three big questions it can answer. Now for the fun part. It's time to see what actually happened in our researcher's study. Let's decode the story that this data has to tell. But first, a really quick but super important detour. Before you can trust the results of a test like this, you gotta check your assumptions. It's like checking the foundation of a house. You run these different statistical checks to make sure your data is playing by the rules. For our case study, all these checks passed, so we can feel really confident in the results we're about to see. And here they are, the answers to our three big questions. First up, was there a change over time? The answer is a big yes. That p-value you see is a measure of randomness. The rule of thumb is, if it's less than 0.05, the result is statistically significant. Here, it's less than 0.001. So yeah, the program definitely had an impact. Second, was there an overall difference between genders? The test says, nope, that p-value is way above our cutoff. And finally, the big one, the interaction. Did the change over time depend on gender? Again, that's a no. So let's just put that main finding front and center. The big reveal here is that there was no significant interaction. What does that mean in plain English? It means that while the program was effective for everyone, the pattern of that improvement was basically the same for both the male and female students. And looking at the actual numbers on this table really shows you why. Just look. For males, confidence goes from about 20 to 23 to 26. For females, it goes from around 18 to almost 21 to 24. See the pattern there? Both groups are going up by about 2 or 3 points at each step of the way. The gap between them is staying pretty much the same. So, if we were to plot these numbers on a graph, what would we see? Yep, you guessed it. Nearly parallel lines. This is the perfect visual confirmation of what the statistics told us. The program's effect on confidence just did not depend on gender. The journey of change was the same for both. So we've seen how our mixed design ANOVA helped us understand the journey of change. But what if we were interested in a slightly different question? This brings us to a really common point of confusion for a lot of people: when to use this test versus a different one called an ANOVA. It all comes down to the story you're trying to tell. Let's just break this down real quick. Our mixed design ANOVA, the one we've been talking about, is all about the change over time. That interaction is its focus. It's asking if the path of improvement is different. But ANOVA asks a totally different question. It basically says, okay, we know people started out at different places. Let's statistically adjust for that. And then it asks, at the very end of the study, after we've leveled the playing field, are the group's final scores different? And really, that's the question you have to ask yourself when you're thinking about your own research. What's the real story you want to tell? Is it about the journey of change itself, or is it about the final destination? Who ends up ahead after you account for where they started? One focuses on the process, the other on the outcome. And knowing which question you really want to answer is how you choose the right tool for the job.